Hi guys, today we are gonna see how to design and analyze the g+4 building. So g+4 building is usually used for the domestic purpose or the office purpose, industrial purpose, etc. So first of all, let us click on STAAD create a software. So wait till it's loading. It is loading. So then this kind of interface will be seen. So in this we will go for the new project. To create a new project of a g+4 building, click on space, let it be g+4 building. g+4 length units be in meters and force units be in kilonewtons. Click on next. This already exists. Sorry, I have overdone it. So let us over again. Okay, then add bin, click on finish. Is it over? Okay, now we generally go for the in geometry, run structure wizard, go to structure wizard. Wait till it's loaded. In structure wizard we have to go for the frame models. In frame models, this kind of frames will be seen. In frame models means this is a bay frame, this is grid frame, floor grid, continuous, etc. are the frames. So in bay frames, the model of the building is been selected. So click on this one, double click. So this is the length of the total building, this is the height of the total building. So this is the width, this is the total width of the building, total height, total length. So then this is the number of bays. That means how many parts does the length is divided. So this length is divided by 4 parts. This height is divided by 5 parts, and this width is divided by 4 parts. If you want, you can change it. So here it is there. You can directly give the values from here, so that different stories. If different stories have different values, click on apply. So this is the structure we will be getting. So this is a g+4 structure. Then click on cancel. Then click on yes. Click on OK. So it is selected. Then go for the read only option. So it is created. Since the geometry is completed, so the geometry has been completed. So first of all, we have to go for the modeling. In here, the geometry is completed. So after the completion of the geometry, we will go for the general. In here, general. Here we have to specify the properties, supports and loads and material. So since it is not having any staircase, we will try to build a staircase. So go for the geometry, click on top view. Okay. Now select this part. So click on right click. So should be selected objects only. Sorry. Wait a minute. So we have to select this one, and after that we have to go for the selection of the section, then go for the cut section. Here this click on XY plane, then so select your view highlighted only, click on OK. So click on 3D model. So the 3D model has been created. So here the staircase should be drawn. Since there are number of this one, so we will be selecting only one floor. So click on display all the objects. So we have to click for only one floor. So then we should be selecting this one floor. So control click on this views. Okay, then now go for the cut section. Selective view, you highlighted, click on OK. So in this way it has been shown. Then now we have to go for this and we have to create the staircase. So click on this beam and click on this beam. After we have to add nodes in between of them. Insert node, insert add midpoint, click on OK. So it has been created. So we have to save it. So save. That's been done. So then click on this one. Click on and insert node, add midpoint, click on OK. So it is created. So now we have to create the offsets of this one. So first of all we have to click on the selecting nodes, then go for these two nodes, select these two nodes and click. We have to give the offsets. So we'll go for the offset to give the offset to the structure. So we have to select these two nodes and if we go for the transitional repeat, so then if it is in X direction, so click on X. So the number of steps are 1. The default spacing be it should be, since it is 3 meters, click on 1 meter. Okay. Now click on since it has been this set, so click on Ctrl Z, then go for the transitional repeat, click on -1 meter since it is in negative direction, so click on this. So in this way it has been created. So next step is we have to add 4 noded plate. So then we have to go for this option. So then select these 4 nodes, select it. So the 4 noded plate is created. So first of all we have to create a node here. So then let us first of all let us draw, or else we can select here node, then select here. So then we have to go for the transitional repeat. Since it is in Z direction it should be about 3, so it is let it be 1.5 meters and click on OK. So here the node has been created. Then next click on this one and let us do it transitional repeat. It is in Y direction, so it is in Y direction, so it should be -3 meters. Click on OK. Then it is created. Since here the plate has been drawn, so then now we have to go for this option and add 4 noded plate. So then click here, and here. Next or else we can give for this to this side also. So first of all we will show this side so that the structure will be neat and tidy. So click on this. We have to simply add 4 nodal plates. So click on this one and click on this one. So the staircase has been drawn. And over here you can see, so in this way it has been drawn. So it is done. So first of all we have to select these nodes delete. So since it is not deleting, so let it be there. So then click on save, yes. So go for the whole structure, display whole structure, and displaying whole structure, so that it is been there. So click on this one. We have to select this plate, so click on the plate cursor. So these plates are selected. Go to 3D view. So we have to do the transitional repeat. So in y direction, how many floors? G+4. This is G is here. So number of steps is 4. Default spacing is 3 meters. Click on OK. So here you can see that staircase has been created. Here you can see that. In front view you can see it. So here now you can see here clearly. This is the staircase we will be providing. In this way the staircase will be provided. Click on the 3D model. It is clearly over. So then next, since the geometry has been completed, we will go for the general. In general, we have to select for the properties. In properties, we will go for the, here the beams, columns are there. So we have to go for the section database. Wait till it's loaded. So going for the section database. Here we have to go for the Indian angle, or else we have to go for a simply we have to define the properties. So since here we will be containing only 2. So then that means beams, columns and thickness of the plates. So then click on rectangle. Click on rectangle is having. Okay, we will be giving for the columns. For columns, let it be 0.45, 0.30. Click on add. Next, it should be 0.35, or else let us take 0.30 into 0.30. So click on add. Click on close. So here. So here now the part, it is for columns, it is for beams. Then we will be going for this slab or the plate sections. Then go for this thickness option. So let it be 0.15 meters. The slab thickness. Then click on add. You can close. First of all, we have to go for this. We have to add the beams. Then so for beams, click on beams parallel to y-axis. Click on assign. Click on yes. So then it has been created. Then now we will be assigning the beams. Then click on this beam. So then click on select. Click on beams parallel to x direction, and again select beams parallel to z direction. So then click on assign. Click on yes. So it has been assigned. So then plates assign to view, assigned. So for the plates it has been assigned. Let us save it. Then click on save. So it has been assigned. After that the specifications has been, the properties has been assigned. We will go for the supports. Here we will go for the front view. Here we have to give the supports. So we have to give the supports to these four. So since it is in node cursor, click on these four actions. So create or edit, create support. This is fixed. Okay, this is being selected. So then has been selected. Use for the assign. Click on yes. It has been assigned. So in this way it has been created. Since the staircase is there, so click on this node and click on delete. Sorry, we have to delete this support. So we have to delete this support. So then we have to go for this. We have to select this support. Or else we can also give supports. Or else we can also give supports. Let us give supports for these three and this one. After that we will be giving for this one. Click on this. Use cursor to assign. Sorry, use cursor to assign. Click on this. So then we have to select these three. Assign to selected nodes. Click on assign. Assign to selected node. Click on assign. Click on yes. Has been created. Then now we have to assign to selected nodes. Click on assign. Click on yes. So then we have to go for this. Use cursor to assign here. Here we can be selecting this 1, 2, 3, 4 and 5. 1, save. On escape. Let us view in 3D. So it is created 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the supports has been created. Next, after giving the supports, we will go for the loads and definitions. In loads and definitions, since it is more than 3 meters, then we will go for the definitions. In definitions, we will be giving the wind load and seismic load. So go for the wind, click on add, click on close, and click on add wind, click on add, calculate as per SIC. So select category 4, basic wind speed will be 44, click on apply, click on OK. So it is created. So click on add. Wind factor intensity is 1, click on add, click on close. So it has been created. So use cursor, let us save it, assign to view, and the exposure. So it has been assigned. So go for the seismic definitions, add. So So here the seismic weight will be coming the so here seismic parameters will be getting of the member weights, element weights, flow weights, etc. So then we have to add this. So in seismic parameters, click on the self weight. So let it be self factor be 1. Click on add. Click on post. Sorry. Click on post. So then seismic parameters will be. Sorry, it hasn't been added. So go for self weight. Click on add. Click on post. So that's been over. Then go for the load phase details. In load phase details, we will be going for the firstly dead load. Sorry, not dead load. So let it be DL. Click on add. Then we have to go for the seismic. So it is a earthquake X direction. Click on add. Earthquake in Z direction. Click on add. Next wind in X direction. Click on add. Wind in Z direction. Click on add. Close. Can also give a live load or the dead load. So since we will go for here, click on add. Dead load means self weight factor is -1. So let it be -1. Click on add. Click on plus. Self weight factor assigned to you. Assign. It is has been assigned. So then next go for the earthquake in X direction. Go for the earthquake loads, that is seismic parameters. So we have done seismic parameters. Then go for the seismic parameters. Click on add. Seismic parameters to only self weight factor. Click on add. Click on add. Because seismic parameters is modified. So we will be firstly finding the seismic parameters. So then we have to specify the seismic. So here we have to go for the seismic parameters. We have to go for the seismic parameters. We have to click on IS 1893 2002 to 2005. Click on generate if it has verification field. So then we have to simply add this one. So click on add. Self weight factor is 1. Click on close. Self weight factor. And then have it. Now simply go for the earthquake in X direction. Earthquake in X direction means seismic loads. Earthquake in X direction means the factor is only 1. So then click on add. So factor. So after X, then we will go for the -1 direction. Click on add. So then we will be going for the. After that X, we have to go for the earthquake in Z direction. So for that, go for the second parameter earthquake in Z direction. Click on this, click on add. And earthquake in Z direction, click on -1. Click on add, click on plus. So then next we have to go for the wind in X direction. So then click on wind in X direction, then click on add. So go for the wind here. So then we have to go for the wind in X direction. So let the factor be 1. So then since our having a g+4 belly, so 3, 5, 3 5 are 15. So minimum range is, so minimum y range is 10. Maximum range is 10 to 15. Since we have the g+4 belly, so it is related to 15. So then Next click on add. Next x direction in -1. Okay, click on -1. Click on add. So then now after it is over, click on cancel. So then after that we'll be going for the wings in z direction. So then click on add. So wind in z direction means click on wind in z direction. Self factor is 1. Click on 10 to here is 10 to 15. Click on add. -1. Click on add. So these are the nodes you should be adding. If you get any error, we have to delete one of these parameters in the earthquake. So we have to assign. So firstly we have to assign self-aid since it has been assigned. Or else we could be assigned again. So it is assigned. We go for the loads in assigned direction. So loads in x1 direction. So in this way the load should be new. So here you can see that. Direction. So since the willing is 50 meters, only the 10 to 50 meters will get the high windy efficiency. So then now we have to. So guys, here the dead load has been transferred to here, in which the only self-rate is active. So it is the earthquake load in this direction. So earthquake load is in this direction, wind is in this direction, so the wind is in z direction. So it has been completed. So after the loads, we have to go for the material. Since the material has already been given, so then directly we will go for the analysis and print option. Click on perform analysis, click on add, click on close, and go for the analyze option. F5. So let us save the structure, and so let it be shown here. So here 0 errors we are getting, and go to post processing file, click on done. So include all, click on apply, click on OK. So here you could see you could clearly see here. If at all, if we get any deflection, we will be seeing here. So here it is here. So then we will be going for this animation here. So click on deflection, click on apply, click on OK. So here we could clearly see that when the earthquake load is active, here the deflection in this beam, deflection in this column and this column. Here some of the beams are getting deflected. So earthquake in z direction. So here we could see that, clearly see that. So in the load we are not getting any deflection. In the load, but also we are not getting. So in this way the animation is being provided. So then wheel here you could go for the shear force in x direction. You could see the shear force diagrams. Here you could clearly see the shear force or the axial force. So next we have here the shear force in y direction. So let us the diagrams here. So you could see here clearly. So the shear force bending moment and diagram will be shown here. Beam stresses, etc. The deflection or the displacement. So it has been completed. After that, we will go for the modeling. Here modeling, we will be going for the design. In design, we have to give the specification. Then go for the select parameters. Sorry, firstly we have to select the concrete. So then we have to go for the select parameters. You can add deselect all. First we go for the FC, F5 main, F6. Click on different parameters. FCB 30,000. Click on add. F main B 5 lakh. Click on add. FCB also be 5 lakh. Click on add. Compose needs to go for the commands. Then on design B, click on add. Design column, click on add. Design slab element, click on add. Or which we could take for window protocol. Click on add. So then it has been created. Then go for the FC assign to view. Assign. Go for the F5 main, assign to view, assign, F5 set, assign to view, assign, bonus, assign to design beams. So in this we have to go for the select command, go to beams parallel to X direction, then select beams parallel to Z direction. So then click on assign to the selected beams, click on assign. It has been assigned. Click on design columns, go for the select beams parallel to Y direction. So it has been selected. Click on assign, click on yes, design element. So you will assign to the click on assign. So it has been assigned to this staircase. Click on let us be right click, and then we will go for the analysis and print. Here then we go for the add and perform analysis. It's okay. Now we have to analyze the structure. Then go for the number analyzing the structures. So let it be wait. Let us wait till the structure has been analyzed before analyzed over. So we will get 0 errors. So then we will go for the view of processing file. So it is been confirmed. So then we will be going for the 3D rendered view. So here now we can see that this is the staircase. This is the 3D rendering view of our. This is the 3D rendering view of a g+4 building. So here now we could see that staircase, and these are the beams, columns. This is the done. Okay guys, thank you.